welcome. This is Mr. TG. This is the final video for lesson 2-3. We have covered so far how to find slopes of lines, how to graph equations that are in slope-intercept form, and then how to put equations in slope-intercept form. And now what I thought I'd show you here today is what, first of all, define what an x-intercept is and a y-intercept. As you can see in your guided notes here, the x-intercept is defined as the point at which the line crosses the x-axis. Now, what we're going to do is just show you, I got a little grid sketched here, but as you can see, the x-axis goes horizontally across. And basically what we're saying, if I would sketch a line, like so, across like so, I'm looking for this point. That would be the x-intercept. Now, if I don't know what that point is, I can make some assumptions. First of all, since the point is right on the x-axis, we can assume that the y-coordinate has to be 0 for that to happen. Again, if it hits the x-axis, the y-coordinate must be 0. Just like if it hits for the y-intercept, we got the x and y-intercept. The y-intercept to exist, that would be this point right here. And for that to work, the x has to be 0. So that's why I've already put one set of coordinates in each of these. X-intercept is the point at which the line crosses the x-axis, and you can assume that y has to be 0. The y-intercept is the point at which the line crosses the y-axis, and x has to be 0. Now, since we know that ahead of time, we can use this to our advantage. Let's take a look at number 3. We're actually going to do some graphing here, and we're going to show you how in some ways it can be easier just to find the x and y intercepts. So the first one, I thought I'd demonstrate, that one's already, number 3 is already in slope-intercept form, so you know how to graph that. But here's another way. First of all, you can put for the x-intercept, you can put y as 0, and for the y-intercept, you'd put x in 0. Now, we already know what the y-intercept is. It's right here. Since this equation is in slope-intercept form, I know my y-intercept is -4. Let's assume, though, that you didn't realize that. Let's say well, I know x is 0. You would plug it in for y. If you put your x as 0, guess what would happen? You would get your y-intercept to be a -4. And that's what you have to do to find the y-intercept. You have to replace x with 0. Just like to find the x-intercept, you have to replace y with 0. So let's do that. 0 equals 2x minus 4. All right, now solve this equation. So you get plus 4, you add 4, and you get 4 equals 2x, so x equals 2. That becomes your x-coordinate of your x-intercept. Now, why this is easier, because these are easily obtained. In this case, we had to do a little bit of extra work, but you can plot those 2 points, 2, 0, 0, -4, simply connect them, and it basically is a way of graphing without knowing the slope, finding the x and y intercepts. Again, to find the x-intercept, simply replace y with 0 and solve the remaining equation. To find the y-intercept, simply replace the x with 0 and solve the remaining equation. Now let's try one that's a little more complicated, and you may wonder, well, why would I want to do that when I can just use slope-intercept form? Well, in Algebra 2, we try and create as many tools as we possibly can to work with. And if you look at number 4, I don't know about you, but I would not want to have to change that into slope-intercept form. We can actually sketch this thing by finding the x and y intercepts. So let's go to work and try that. So a lot of fractions. Let's do this. If the x-intercept exists, I think hopefully you know that y has to be 0. So we're going to put 0 there for the x-intercept and put 0 for the x for the y. It's just the opposite. And hopefully that makes sense why you do that. Don't just memorize. If my line crosses the x-axis, y has to be 0. If it crosses the y-axis, x has to be 0. That's just the way it has to work, even though we don't know exactly where that point is. The next step is to take your equation, to find the x-intercept, and simply replace the y with 0. So we got 1/2 times 0 equals a -1. Now we're going to later this particular equation, what that's going to do for us is just going to make this go away. That's going to just zero out of our problem, because anything times 0 is 0. We're left with -3/4 x is equal to a -1. So all we have left to do now is solve for x. Now this has a fraction in it, so I'm going to multiply both sides by the reciprocal of a -3/4, which would be a -4/3. If I do that, this all cancels out. Everything goes away over here, leaving me with x equals 4/3. Or if you want, you can write that 4/3 as 1 1/3. That would be your x-intercept. Okay? So again, I have to erase this, but again, to find the x-intercept, put y as 0 and solve for x. Now let's do the opposite. Let's erase and just find the y-intercept. We're going to find the y-intercept. Now we got to put the x as 0. So if we do that, you end up with -3/4 times 0 plus 1/2 y equals a -1. Again, we know that this term just goes away. It's 0. So we're left with 1/2 y equals a -1. And we multiply by 2. So y equals a -2. That's a -1 there. That becomes your y-intercept. Y equals -2. Then what we do is we take, if we're going to graph this, we know 2 points that are on our graph. 1 1/3 is approximately right there. That's our x-intercept. -2 is our y-intercept. Just sketch it, and there's your line. So this is just another way of graphing. If you know, if you don't want to change the equation to slope-intercept form, like number 4 would be a very difficult task for us to change it to in slope-intercept form. So if you want to just find the x and y intercepts, you can. The disadvantage of that, of course, is you don't know the slope until you actually sketch the line. All right, so that's finding the x and y intercepts. Hopefully that went well for you, and good luck with this lesson.